Hello, good morning, guys. I want to make another attempt at the videos again today. I just hope it works. Like I said, there are many things that I wish to demonstrate to you guys, and I hope that I'm able to do it. So you just please follow me step by step. On the exam day, you'll be asked to design a linkage and simulate and analyze your results. For that one, it will not be expected of you to use the layout interface, although there will be other questions that will require that one, but the main one you have to use just your normal part design and then your assembly interface. I have already made the parts and I've saved them in a folder, so I'm going to go straight to assembly. So you see the screen the way it is. This is new, right? When you click on this, you're going to have a dialog box letting you choose between parts, which is already highlighted as you can see here, assembly and drawing. We want to assemble. I have already done the part. To do part, you just click here and you are in. But for assembly, you click this, right? For those of you using lower version like 2014 version, this is not the way it is displayed. However, the part, the assembly, and the drawings are okay. They are distinctly displayed. So I'll choose this one and then click OK. Yes. So here I'm in my assembly interface. We are not creating layout. We are just going to put the linkages we have done before together. And that's what we want to do. So I'm going to cancel this, right? So when you click on cancel, this place changes, right? Now when you look at this, you see that we have insert components. This is what we want to do. So I'm going to insert components now. When you come here, you see that there is nothing here. For some of you who are going to be working that day, after drawing the parts, you may just press Ctrl N on your keyboard and that will open a new part. You are not going to close the window for the part that you have designed. So as you keep on doing that, by the time you now come to assembly, you see all the parts that are opened will be here, because this is the only screen open now, the only window open now. There's nothing here, so I have to browse to the folder where I have kept my parts. So I'm going to click on browse. Now the folder is open. The folder is linkages. Okay, so I have done my ground link, my crank, my coupler, and then my follower. So I'll click on this, which is the first one I want to drag in, open, and then see it appears here and also appears here. So when I bring it here, I'm just going to click on the workspace and it positions itself. All right, now it is like this because it is displayed as isometric. You see it. So if I want to change it to front view, this is front view. All right, it's either I press this or I press Ctrl 1. That's a shortcut. So just come here. You see, now by default, this first part brought into the assembly is fixed and will never move, so it is a ground link. Okay, so we are going to leave this one as our first link. Then we are going to bring in the crank. Okay, this is my crank. So that's my crank, and I'm going to mate these two components now using mechanical mates. It's always good to use mechanical mates, at least show the stuff you are made of. You are different from every other guy out there. So here the concentric faces or selections are made. Then here I have to now select the coincident selections, this face and this face. So there I have it. You see? Yeah. So then I'll bring in my coupler, click open. Yeah. So I'll position my coupler here. You see, because of arrangement, I'll place my coupler on this side. So I want to mate. Of course, you see mechanical mate. I want it as a hinge. So I'll first of all choose my concentric selections. Alright. Then by coincidence, this face, and of course this face. Oh, sorry, I didn't get that correctly. Second hinge, I'm going to edit it. Sorry, let me clear this. Sorry, I'm just going to clear the new selections. To delete it. Good. So I have to enter it again. Yeah, so yeah. Okay. So this face and this face. Yeah, got it now. So this looks a bit okay. Then I want to bring in the other component now, which is the follower. Of course, I want to meet. What we want to do next is a bit more like what you are not familiar with, but I'm going to do it for the purpose of those of you who want to explore. Okay, you see the way this ground link is designed. It's a bit different from what you are used to. You've always been used to having a ground link as either this one fixed or something like this or something like this, right? But I've made it a bit different now, and this is to enable us have building some kind of offset rather, which is we want to have it as eccentric, distance between this and that. So I'm going to mate. Okay, I want this place and this one to have some distance apart. I can leave it at 125 mm or 130. It's okay. I want this face this face to be coincident, right? Then I want this button here to be parallel. Let's check if it can still move. This face and this face to also be parallel. But next I want to give this place and this one some distance. Make it like 40. That should eventually fully locate the other one. See, it's not able to move anymore. You see? So it's fixed now. Then we can couple the other part to it. So we made once again mechanical mate our hinge. This and that. This and that. So here we go. our 4-bar linkage. It's a 4-bar linkage because this and this make up the ground link, which is 1. This is the ground, which is 2. This is the coupler, which is 3, and this is the follower, which is 4. So we've done this now. The next thing for us to do is to do a kinematic analysis, and then we'll come here, which is our motion study. See all the things we need. Remember that without activating the SolidWorks motion analysis, we'll be able to do just 2 basic things here: animation and basic motion. Alright, but this is not what we want. We want to do motion analysis. In other words, we want to be able to analyze the system to get the position plots, displacement plots. We want to be able to get velocity and acceleration. So you come here under options and click on add-ins, and then you have your SolidWorks motion. You see the display here has changed, so we'll be able to locate our motion analysis here now. Good. So the first we want to do is to energize this. In other words, apply a degree of freedom. This is 1 degree of freedom system, okay? And so we want to apply that 1 degree of freedom, which is the angular rotation. And here is a motor, which is a design parameter to help us do that. And we want rotary motor. There are options for the different types of motor that you can use. Okay. So we want to apply our motor to location. Yeah. And then all the direction reversed. Okay. The way we want it oscillating, constant speed, of a certain distance, segment, data point, expression, 7 motor. Okay. We want it at constant speed, so we'll leave it at 50 RPM. We should be okay with that. This is taken at 5 seconds initially, which is okay. So let me calculate now. Oh, great. So I'm going to play this now. Excellent. So it's giving us that. Now when you look at this pin here, you're going to see a little plot here. This icon here is for results and plots. So this is where we do our analysis. Alright, so I'm going to click on this. Here you select your result category to see the options that we have here. So we have displacement, velocity, acceleration, which is actually the crux of kinematic analysis. You are not interested in forces, you are not interested in momentum, energy, and power, you are not interested in other quantities, you are just interested in this. Alright. The study of motion, the geometry of motion, that is kinematic analysis. And so here we want to look at well, displacement may not really give the design engineer the kind of intimacy you need for what goes on, to understand what goes on in your machine. If they are out of balance, out of balance masses, they could create damage by acceleration is present. So but this would suffice for static analysis, but not for dynamic. So you want to be intimate with a better picture of what happens. You want to have a better perspective of your machine. So let's look at linear acceleration. Mass times acceleration gives you force, right? So you could have an out of balance mass, and if it's accelerating by reason of its position on your linkage, wow, that could be devastating. And you want to be able to provide that. So let's see the X component. So here we select let me look at it. So let me point here. Good. So create new plots. This will be okay. All right. So we've got it. So I'm going to just activate again. Yeah. So see, this is our acceleration time plot. The acceleration time plot. Great. So you can go ahead to add other results and all of it. But what I'm most interested in right now is the curves. Alright. So we should be able to trace curves. Now to be able to get the curves, you also have to look at displacement, velocity, and acceleration results category, and the subcategory trace path. And then here you just choose the point you want it. I want to see the coupler curve, so I'm going to look at this edge here. Yeah, so you see, that's it. And then calculate again. Great. You can also make videos, video animation of this, whatever you want. This is it here, but that's not really our interest right now. So guys, I hope this video works, and all right, bye for now.